section with systems of equations in two variables. 7.2, the next section would be systems of equations or linear equations in three variables. So for this section, basically an introduction, very straightforward, not difficult. So let's look at it. Systems of equations, basically in chapter 1, we introduced, well, you saw it before, even going back to previous math courses, the equation of a line. And so there, the goal was to be able to graph a straight line. Here, what if we talk about more than one straight line? What if we talk about two straight lines? And then the question is, do they cross? Well, if they cross, well, where is that point of intersection? When we call the point of intersection the solution. So where lines cross, we say that that's a unique point, and that's called the solution point. If they don't cross, if they never cross, then the question is, does that mean that the lines under consideration are parallel? Well, that's a possibility. If two lines never cross, then they must ideally run parallel to each other if we're talking about straight lines. The third possibility with these lines is that the equations under consideration all coincide to one equation. So where we think that we have two or three lines, basically we have one. And we say that every point on that line is a solution of what we call infinitely many solutions. So that's what we have, and here's an example there of system of equations. We have two equations, x plus y equal to 7, x minus y equal to -1. A very intuitive way of solving here is what we call by substitution. That is, if you got two equations with two unknowns, x and y, then I can take one of those equations, solve for one of the variables. That is, just write x by itself or write y by itself, your choice. And then take that solution, take that idea, that statement that you have there, and plug that in or substitute that into the next equation, and then see if you can solve for one variable. Once you solve for that variable, take what you had substituted, this so-called formula, back, and then hopefully you can get the original variable. So let's see what that looks like. Sometimes talking is cheap. Solving linear equations by substitution. Again, you can take one of those equations, and what these steps basically say, take one of the equations, solve for one of the variables. Now, when you solve for one of the variables, does not mean that I'm saying I'm going to get x equal to 5 or y equal to 3. I'm going to get something like y equal to 3x minus 1, or x equal to 1/2 y plus 5. We get something like that. Take that form and plug that into that other equation, and then you'll be able to solve for one of the variables. And then once you get that value back, substitute that in to what you had started off from step number 1, and then you get the original variable. Let's see how that works out. And again, talking is cheap. Now, solve the system by the substitution method. So you have x plus 2y is equal to -1, and then y equal to -2x minus 14. Now, this problem, the first step is already worked out for us because they've already gotten y by itself for that second equation. You see that? They got y equal to, sitting out there by itself, y equal to -2x minus 14. So they've done the work for us. That's good. So this is step number 1. So step number 2, I'm going to take this form for y, this is y equal to -2x minus 14, and I'm going to substitute it in here. So I have, for the first equation, x plus 2 times y, but y is said to be -2x minus 14. close that up, that's equal to -1. Do you see what I did? Does that make sense? All right? Okay. So now, here in step 2, I can solve for x. So I get x minus 4x minus 28 is equal to -1. So basically, this is our step number 3. So step 3 here, solve for x. So this gives me -3x. Let's add the 28 on both sides. That's equal to 28 minus 1, I get 27. So then I get x equal to -9. Right? Step number 4 says back substitute x equal to -9 back into step number 1. You see that? Because in step number 1, you already have y equal to -2x minus 14. Since I know what x is, I can plug in that value for x in step number 1, solve for y. So here, this is y is equal to -2 times x. Here, x is said to be -9, and that's minus 14. So I get 18 minus 14, and that gives me 4. So the solution set is an ordered pair. That means that it has two values, pair. And the pair that we get is the -9 comma the 4. And you plug that here. Now when you do that, make sure that you put that in parentheses. What I do is, before I come here, I go into my math lab and do all the problems myself, just to make sure that I understand the technical situation with my math lab, so I can tell you. And that is, when I work this, I just put in for the answer for A, I just put in -9 comma 4, and it kept saying it was wrong. I was like, no, it's not wrong, it's right. And so then I typed it back in again, -9 comma 4. It said, you're wrong. Bless you. I said, I'm not wrong. I know I'm right. So, I had a verbal dispute with my computer in my math lab. And so something said, well, just put parentheses around -9 comma 4. And then it said, excellent, great job. I was like, shut up, So, so must type in parentheses. All right. So here, solve the given system by the substitution method. So what we're going to do is we're going to do step 1. I'm going to take that. It doesn't matter which variable, which equation that you get. Personally, I try to get the one that I think is going to be easiest to get, if all possible. Notice for that second equation that x is by itself. So I'm going to try that. So here, I get x is equal to 3y. Does that make sense? X minus 3y equal to 0. Add 3y to both sides. X equal to 3y. So now step number 2, I'm going to go to the first equation, and I have 5 times x, but here x is said to be 3y plus 4y equal to 0. Step 3, here, solve for y, because I get y and y, right? Y and y, and so you ask why. Math joke, not funny anymore. Okay, so solve for y. So this is 15y plus 4y equal to 0. 19y equal to 0. That implies that y is 0. Right? Step 4, go back to the to step number 1, I have x equal to 3y, 3 times 0, x equal to 0. Right? Now, here is just some an inside scoop on systems of equations. If you ever run into it, you don't have to go through all of the steps if you know what's happening, and that's this. If you have a system of equations where the number of unknowns equal the number of equations, and if all the equations are set to equal to 0, then automatically your solution would be the trivial set. The trivial set, or the trivial solution, is x equals 0, y equals 0. Now again, let me go back over that. If I'm given a system of equations, and first you notice that everything is set to equal to 0. Each equation is set to equal to 0, right? If the number of variables, x and y, have 2, equals the number of equations, right? 2 equations, two unknowns, right? So if I have that, and number 3, all equations equal to 0. Number 4, your solution will always be the trivial solution. Here, x equal to 0, y equal to 0. That is 0, 0. If it's 3 equations, 3 unknowns, and each equation is set to equal to 0, then my solution would be x equals 0, y equals 0, z equals 0. You're done. Okay? That's a theory in linear algebra. All right. Now here's the critical thinking. This only works when the equations are set to equal to 0. All equations set to equal to 0, and again, the number of equations matches the number of unknowns. 2 equations, 2 unknowns. X and y, 2 unknowns. I have 2 equations. Each equation set to equal to 0. That then automatically, I mean, you can go through the steps like we just did, 1, 2, 3, 4, with these steps over here in solving, and you still got x equals 0, y equals 0. I'm telling you, in the future, if you see that up front, then don't waste your time. You know that you're going to have the trivial solution. Now, the critical thinking piece is this. You can't apply that to anything else. Like if you got 2 equations, and one equation set to equal to 0, and the other equation set to equal to 4, you can't say that I have the trivial solution. You see that? Or if you have 2 equations, 3 unknowns, and they're both equations set to equal to 0, I can't apply that. Again, if I have 2 equations, 3 unknowns, and both of those equations are set to equal to 0, do I get the trivial solution? If I have 2 equations, 3 unknowns, and each equation is set to equal to 0, do I get the trivial solution? That's my question. Let me write it out. Does the system here, x minus 3y plus z equal to 0, 2x plus 4y minus 5z equal to 0, does this system yield the trivial solution? Does that system yield the trivial solution? Does that system yield the trivial solution? That's my question. Talk to me.
I'm not sure.
Why are you not sure?
I don't really get that. I don't understand the trivial solution.
Trivial solution means x equals 0, y equals 0, z equals 0. Trivial solution means that I get the origin for my solution.
Okay.
Look, I have it here. When I was, this is over here on the left side. This is a theory from linear algebra. I just wrote it like this. Will always be the trivial solution. I'll tell you what it is. X equals 0, y equals 0. You don't have to believe that theorem. What I'm saying is you can work the problem out and see what you get. I just worked this problem out. 5x plus 4y equal to 0, x minus 3y equal to 0. I worked it out with the steps, and we got x equals 0, y equals 0. But I'm telling you, if you don't know the insight is if I have a system of equations, and each equation set to equal to 0, and the number of unknowns equal the number of equations, then automatically the solution will always be trivial. So my question down here is, does this system of x minus 3y plus z equals 0, 2x plus 4y minus 5z equals 0, does that yield the trivial solution?
Yes.
You say yes. Okay, why do you say yes?
Because I don't have x and y equals 0.
Because, say it again now.
X and y will equal 0.
But this is x, y, and z now. X minus 3y plus z equals 0. 2x plus 4y minus 5z equals 0. Does this yield the trivial solution?
No.
No. And why do you say no?
Because you need z to equal 0. You need the z to equal 0.
Not necessarily. The reason why I don't get the trivial solution only here is because I have 3 unknowns, x, y, and z, in 2 equations. Look, this says that if I have the number of equations is the same as the number of unknowns, and each equation set to equal to 0, then I automatically get the trivial solution. So for this example here to work, I got to have another equation of x, y, and z. I got to have 3 equations, 3 unknowns, and each one set to equal to 0. And then I can say automatically I get the trivial solution. Other than that, I can't say that. Can't say that. Well, the goal of mathematics, my friends, is not for you to take a problem and then just immediately just get to your paper and just work and stuff, and you just say, what are you doing? I'm doing math. What are you doing? I don't know. I'm just trying to get these numbers, and we don't know what we're just doing. I mean, that's, don't do that. That's not the goal in life. Mathematics teaches us that if I'm given a problem, analyze it, examine it, study it, think about it. Does it make sense? What sense? Does it make mathematical sense? Does it make logical sense? And then, look, do I understand what it's saying? Because if I don't, then let me go and look up what it's trying to say so I can understand what it's talking about. So then I can give an educated answer. Okay? So, anyway, just something to make you think and get your coffee brewing really good this morning, Bless your hearts. Okay, so there's another method. We have the first method is called by substitution. I can solve a system by substitution, or I can solve by what's called the addition method. Now, the addition method is really not the name for it. Is really the elimination method, or the so-called Gaussian elimination, named after Carl Friedrich Gauss, French mathematician, in the 1700s, who deduced a whole lot of things in mathematics. One was he dabbled with systems, and so what basically he gives to us is, in solving a system, he said, if I look at equations, you can eliminate a variable by maybe adding one equation to another equation. He says, not just adding, but you may have to add a multiple of an equation to another equation. Here the goal is you want to be able to cancel out a variable. So, so let's see. So here, solve the system by the so-called addition method. This addition method or elimination method, is it possible that if you add equations, are you able to cancel out a variable? Well, here's what they do for this particular problem. For this problem, they set it up where if you add these two equations directly, you're going to automatically cancel out the y. Now, that's not always the case. Most times you have to actually do some work to be able to cancel out that variable by adding. But here, let's just take just a very elementary case where they got it set up for us. You look at the first equation, 2x plus 14y equal to 4, and then 2x minus 14y equal to 4. Now notice that if I add these two equations, then automatically the y cancels. Okay? So here in adding, I get 4x is equal to 8. Now again, in most situations, I have to actually do some work to be able to make the cancellation. But here it's kind of set up for us. So if that be the case, then I get here x is equal to 2. Now take x equal to 2 and plug that into any one. If I was, at home down in South Central Alabama, I would say and 1, take x equal to 2 and plug that into any one of these equations to solve for y. So if I take the first equation, here take 2x plus 14y equal to 4, and then in x equal to 2. So I get 2 times 2 plus 4y equal to 4. Subtract 4 on both sides, I get here 4y equal to 0, and that implies that y is equal to 0. So that gives me x equal to 2 and y equal to 0.
Why did it go from 14y to 4y? Why did it go from 14y to 4y?
Where are you?
Like at the top it's 2x plus 14y equals 4, and then you plugged in the 2, and now it's 2 times 2 plus 4y equals 4.
Oh, it should be 14, I'm sorry.
I didn't know if I missed a step.
No, I just lost my 1.
Okay.
Yeah, thank you. Yeah, I'm not trying to create new math. Yeah. Thank you, sir. Very good. All right. Here, solve the system of equations by the addition method. So I have this as the class assignment. So here's the goal. Here's what we want to do. I need to be able to, in some kind of way, add the two equations to cancel out one of the variables. And the variable that you cancel out is your choice. You can say, I'm going to cancel out the x. Or you can say, I'm going to cancel out the y. Let's say we want to cancel out x. Let's say that. So to cancel out x, what do I have to do to to make sure that x is canceled out in the addition of both of these equations?
Will you say that one more time?
Okay, it's called the addition method, right?
Mm-hmm.
Well, that means that in some kind of way you want to add two equations to be able to cancel out a variable. Obviously, if I add those two equations right here, I'm going to get 10x plus 5y equal to 50. X and y didn't cancel, right? So here, again, I said, it's your choice in terms of if you want to cancel out the x or if you want to cancel out the y. Your choice, which approach you start. So I'm suggesting, let's say we're going to cancel out x. So what must we do to cancel out x?
Multiply them by each other. I keep multiply the bottom by 8 and the top by 2, right?
Okay, I mean you're there, but you're too advanced. Let's say that. What if? Because you're thinking about the same thing. You're thinking about, because there you would get 16x and 16x, right? But since 2 is a multiplier of 8, then no need to multiply the 8 by anything. Just multiply that second equation by a negative 4,
Right.
and that'll give you negative 8x, right? So don't try to make the numbers big if you can help it. So do we agree that if I multiply the second equation by negative 4, from there I can cancel out x by adding the two equations, right? Does that make sense?
Yes, sir.
Okay. So here, to cancel x, multiply the second equation by negative 4. Okay. So I have here 8x, just putting the, what happened? Just writing the first equation, minus 3y equal to 40. And then we're going to say here negative 4 times this equation, and that'll be negative 8x, and then that's minus 20y is equal to minus 40. Okay? All right. So let's make sure we check our math. So negative 4 times 2x is negative 8x. Negative 4 times positive 5y is negative 20y. And negative 4 times positive 10 is negative 40. Now I'm going to add the two equations. Now when I add, indeed, they cancel. And so here I have negative 23y is equal to 0. So that just gives me y is equal to 0. Okay. So if y is equal to 0, then I'm going to plug in y equal to 0. So here, now take y equal to 0 and back substitute it into any one of the original equations to solve for y. So let's take the first equation. So if 8x minus 3 times 0 is equal to 40, so I get 8x is equal to 40, x is equal to 5. So my solution set would be 5 comma 0. Okay. Does that make sense?
Yes, sir.
Now, again, it's called the addition method, but the actual method is called the elimination method. And later on, if you're an engineer, you have to take linear algebra. We introduce it as Gaussian elimination. So the goal is to be able to add two equations to be able to cancel out a variable. And so sometimes just adding directly doesn't cancel out a variable, so you may have to manipulate the equations to cancel out the variables. Okay. So I don't know how this slide got to the end of the section. It should have been toward the beginning. But I had talked about it, but I wanted to have the graphical illustration, and that is we talk about these systems of equations. Our solution could be one of 3 types. Could have the unique solution. The problem that we just got through doing, they all had the unique solution. That is, we were able to find a point of intersection. So, unfortunately, none of those problems gave us no solution. And if it's no solution, it's going to be obvious, because basically when you solve that system, you're going to get something just wacky and just doesn't make sense. Like you may get 6 equal to 8, or 0 equal to 5. Well, that's impossible. So that's going to be a no solution. Infinitely many solutions simply means that the two equations, when you go to solve, they cancel out each other. And it's like, what happened? Everything went away. Well, that's because you're just talking about one line or one equation, basically. So, so that's what we have there. And any questions? Any questions on this section? This is 7.1, is the introduction. So let's look at 7.2, which deals with basically the same idea, but it just raises it now to 3 equations, 3 unknowns. So I want to be able to solve for x, y, and z. That's a little bit more trickier, and so the techniques are a little bit more advanced than what we saw here.